Hi, I'm an old guy and I do maths. Today we're looking at hyperbolas, rectangular hyperbolas, and just their general equation, and from their general equation how we work out what they look like. So the general equation of a rectangular hyperbola is what you see here. It is x squared over a squared minus y squared over b squared is equal to 1. Right, well, so we have four moving parts, x, y, a, and b. And how does this all sort of wash out? Well, I think the first thing to say is that these hyperbolas, surprise, surprise, have asymptotes. And if you're used to the hyperbolas that you might see in some maths books at high school, these look different. The hyperbolas that you may be used to seeing occupy, if they're positive, occupy an area here in the first quadrant, and they have this curve, and they do have asymptotes. Again, the general equation for those puts the asymptotes at the y-axis and the x-axis, and they sweep down like this and like this. These are somewhat different, and they're somewhat different because of the way in which they are formulated. This looks nothing like the way in which you would write the equation for the hyperbolas that you might be used to. Okay, so let's get on with it. As usual, the first thing that I would do when I'm looking to graph one of these things is, having sorted out the equation and got it into this form, because it may not always present in this form. It can present as a single line, which can be quite deceptive. Anyway, so having got it into this form, I'd go about finding the asymptotes, and that's reasonably simple because there is a formula for the asymptotes based upon this equation in this form. And the asymptote with the positive gradient is a linear equation. Y is equal to b over a times x. So you have the constituent parts here, and you can work out the asymptote for this. Now, the other asymptote should be, if you've done everything correctly, perpendicular to that. And indeed, if you look at the equation, the only difference between this equation and this equation is that this is negative. So this angle down here should be 90 degrees. If it's not, and you're dealing with a hyperbola, you know that you're dealing with a hyperbola, then something has gone wrong. Okay. Now, the basic shape of the graph itself is, as you see here, as best I've been able to draw it. I've highlighted it in red so that it stands out. And it has two intercepts, or the constituent parts of the graph have two intercepts, one on the positive side of the x-axis and one on the negative side. And again, these are fairly easy to calculate once you've got your hyperbola in this form. The intercept here is a, the square root of this, positive a, 0. And the intercept here is the negative square root of this, negative a, 0. And that's pretty much it. Because these are asymptotes, this graph will never touch this, nor will this graph ever touch this. And that's fundamentally it. That's how you work your way around one of these things, provided, and it's a big proviso, provided that you've got it in this form, or you've been able to put it into this form. Once it's here, it's very, very easy to work with. And yes, these things can move about. This is a very basic hyperbola here. You can move the center of the or the intersection of the asymptotes up, across, back, down, just as you can with any other graph. And we'll look at how that is worked out in a later video. So thank you very much for watching. I hope you found this useful. If you did, please like and subscribe, and I will see you next time. Bye.